Hi, my name is Lily Lopez, and today I will show you an example on trig proofs. So the problem that we're going to go over today is going to be cotangent square t minus 1 over 1 plus cotangent square t equals 1 minus 2 sine squared t. So the first thing that we're going to do is we're going to change the cotangent squared t in both the numerator and denominator using reciprocal identities into cosine squared t over sine squared t. And that's going to be minus 1 on the numerator, and then on the denominator it's going to be 1 plus cosine squared t over sine squared t. And if you notice, there's fractions in both the numerator and denominator, so the whole fraction is a complex fraction. And the way that we're going to simplify it is we're going to find the common denominator for the complex numerator and the complex denominator, and then we're going to simplify it. So the way that we're going to do this is that we're going to start with the numerator. So in the numerator, there's cosine squared t over sine squared t. And what we're going to do is we're going to get the 1, and we're going to think the 1 as 1 over 1. So it's going to be minus 1 over 1, and we're going to times that on the top and bottom by sine squared t and sine squared t. Okay, there. And we're going to do the same thing on the denominator. So we're going to times the 1, we're going to change the 1 to 1 over 1, and then we're going to times it on top and bottom by sine squared t, so that it can have the same denominator. And we can move this around, so it's going to be cosine squared t over sine squared t plus 1 over 1, and then we're going to multiply it by sine squared t, right? And what's going to happen to this, it's going to end up being sine squared t over sine squared t. And what's going to happen to this is going to be the same exact thing, so it's going to be sine squared t over sine squared t. Okay, and then after that, we're going to combine everything in the complex numerator and denominator so that we could change the numerator into only having one single fraction, and that we could, for the denominator, to only have one single fraction. So you'll see here. And now, since we have the both common denominator, we could add them. And then we could subtract them on them. It would be cosine squared t minus sine squared t over sine squared t. And then on the complex denominator, it's going to be cosine squared t plus sine squared t over sine squared t. And the way that we're going to divide cosine squared t minus sine squared t divided by sine squared t is that we're going to change this division sign into a multiplication sign, and we're going to flip this fraction. So what we're going to be cosine squared t minus sine squared t over sine squared t. And here we're going to change it to multiplication, and we're going to put sine squared t on the top, and we're going to put cosine squared t plus sine squared t on the denominator. Cosine squared t plus squared t. And we cancel out the sine squared t and the other sine squared t right here. So we're going to end up with cosine squared t minus sine squared t over cosine squared t plus sine squared t. And we're going to be able to change the denominator into 1 using Pythagorean identities. So, it's going to change into 1 for cosine squared t minus sine squared t. It's going to look like that. And then we're going to be able to change the cosine squared t into 1 minus sine squared t using Pythagorean identities as well. And then we're just going to combine like factors, so the sine squared t and the sine squared t, so it's going to be 1 minus 2, because there's 2 sine squared t's, and it's just going to be 1 minus 2 sine squared t. And that's how we got the left hand side to equal the right hand side.